Let's enjoy one more example of a hypothesis test involving a mean. This is based on an experience I had once. Oh good, Grandpa's got a story. Oh good. So one time I was on an elevator, and just a poor guy trying to make conversation turned to me, and this old guy says, "Boy, it sure has been hotter this month than usual." And it was in July. And I said, "Well, I don't know, sir. It sure seems like it's been hotter than usual, but I think we should put that to a hypothesis test." And he says, "Good idea, young man." So here's what we decided to do. We went and looked up what the historical average high temperature is in Topeka in the month of July, and we found out that it's equal to 89 degrees. Myself and this gentleman on the elevator. So the historical average high temperature in Topeka is 89 degrees, equals. So weren't we going, if we're going to test his hypothesis, my new friend on the elevator, that it's been hotter than usual, then wouldn't that mean that the average for this particular month was greater than the historical 89? Hotter, higher, right? So his original statement that this particular July has been hotter than usual, doesn't matter what words you use, but that was his original statement, right? Boy, it sure has been, the temperature this particular July has been higher than usual, all right? Significantly higher. And he understood, he agreed with me that we needed to check to see if it's really significantly higher. All right, so then I said to him, "So what do we do now?" And he said, well, he pulled out his phone, we're on the elevator, it's going down, and he goes, I'm gonna real quick look up 10 randomly selected days during that particular July, all right, and all that kind of stuff. And so we took those 10 temperatures for that month of July, and real quick we added them up and divided by 10 to get an average of 91.2. And then he did the standard deviation, because he knew that formula, and found out that it was 3.4 degrees for those 10 randomly selected days. Now, that would be important, because then I said, "Hey, sir, wouldn't it be true that since you just calculated the standard deviation for your 10 randomly selected days, then that would be a sample, all right? And then, is that population normally distributed?" And we looked it up, and it was, and it says so in the narrative. So he says, "Well, it looks to me, young man, like we're going to be using a t-test on this one." And I said, "I agree, sir." One of the few people that have called me a young man, okay? So anyway, if you go back and read that question, you'll see that it is normally distributed. Temperatures in Topeka are normally distributed. And again, we calculated the standard deviation for these 10 randomly selected days that my new friend looked up on his phone, as it says in the narrative there. When 10 randomly selected days were chosen, the standard deviation was 3.4 degrees. Standard deviation, 10 randomly selected days, that's a sample. And it says normally distributed. All right, so then I said, "Hey, sir, you happen to have a tea table on you?" And he said, "Well, as a matter of fact, I do." I said, "Well, good. I think I have it memorized, but it's good to have a table with us as well." He pulled one out of his wallet. But anyway, this would be greater than, so it'd be in the upper tail. So we're going to put that 5% in that upper tail. And remember on this one, you don't need to know the middle sliver. This table is different. Okay, but the two things, and I said, "Oh, what do we need here?" And he said, "Well, we need alpha, and we also need degrees of freedom." And again, we only had time to look up 10 days. So 10 minus 1 would be degrees of freedom of 9. And actually, I lied earlier. I'm the one that had the tea table in my wallet, whereas my new friend had it memorized. And so if we look for a one-tailed 5% with 9 degrees of freedom, and I was looking at the table that I pulled off out of my wallet, and I said, "Well, sir, do you get 1.833? And he said, "Yep, that's what I got. That's what I memorized." So we're going to reject that null hypothesis if our t-value ends up being greater than 1.833. Remember, we're doing a t-test here is what they would call it. Because again, the flow chart that we talked through led us to that. So there we go. And now the elevator, it was stopping every now and then. People were getting on and off, and we were asking them their opinion of this. And it was getting pretty close to being at the bottom floor, so we really had to hustle here. And so again, he took those 10 randomly selected days for that particular July and crunched out the mean and standard deviation. And the mean was 91.2, which I'll point out is indeed higher than 89. But is it significant? I mean, that's not a very big difference, is it? I don't know. So, x bar minus mu, the mean of the 10 selected days that my friend looked up, the mu, the mean for a typical July. All right, standard deviation was the 3.4 degrees, and the fact that 10 was our sample size. And I had a calculator with me, as I always do, so I was sitting there poking buttons. And again, my new friend was just crunching it out in his head. And so I asked him, I got done pushing those numbers into a calculator. I said, what'd you get? And he says, I got 2.046. What'd you get? And I said, yep, that's what I got with my calculator. This guy was brilliant. He could just do these computations in his head. So I'm like, oh, we better hurry. We're on the 3rd floor. We're almost to the bottom floor here. What do you think, sir? Well, that is out there in that upper tail. Yeah, 2.046. That is out there. That is beyond the 1.833. I guess we're going to reject the hoe then, aren't we? We're going to reject that null hypothesis. Because we got a significant, it is beyond the 1.833 threshold here. And so it looks to me like that 2.046 would lead to rejecting the null hypothesis. He wasn't eating tater tots. I was going to slap him out of his hand, and say, don't you bring that weak tot action. But anyway, based on the question that was brought up, it looks like indeed, using 5% significance, it can indeed be concluded that the mean high temperature that particular July was significantly higher than the historical average. So, as the doors opened on the final floor, I said, you know that thing you said to me up at the 35th floor, where you said it was hotter than typical July? Yeah, I agree with you, using 5% significance. So, have a nice day. Indeed, your statement held up, that particular July, it was hotter than typical. So indeed, it was hot in Topeka that particular July.
As a cold front sweeps in, you can expect showers in Spokane.
My video's not working.
Showers in
Darn it. I
Spokane.
don't know what's wrong with my videos.
Spokane.
Sorry.
Temperatures are up there, and it's hot in Topeka.
It's hot in Topeka. It's hot, 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 hot. Hot. It's hot in Topeka. Topeka. I'm a Topeka. I'm a hot Topeka. Pick my toe, it's hot. Pick my hot toe, pick it. Topeka's hot. My toe is hot. Pick it. It's hot in Topeka. It's hot. It's hot. It's hot. It's hot in, it's hot in, it's hot in Topeka. Topeka.
Anyway, sorry for the technical difficulties. It's a cartoon. It wasn't playing technical difficulties.
It's hot in
Topeka. Anyway, sorry, technical difficulties. Anyway, go to YouTube and look up Hot in Topeka. You'll get to see the video if you want. But that should conclude 25-26. And again, you'll have 6 questions, 4 points apiece. Make sure you show all the steps as we did here. And I wish you the very best, and get those to me as soon as you can, all right? And we're pressing on. It's hot in Topeka.